Good evening students, welcome to basic electrical lectures. So in this lecture that is module 4 DC generator, in that we are doing class number 3. In this lecture I am going to explain the construction of DC machine in detail. Okay, and this is a very much important question for university exam. So far you people are writing, current batch is writing 5th time, or in that already 4 papers over. In that 4 papers 2 times asked this question. So it is very much important. Explain the construction of DC machine with need sketch. See, first you should draw a need sketch. What you need to explain means, so there will be a parts in the DC machine. Each and every part you should explain. What is the function of it and what are the parts made up of. Regarding that you should write some explanation. Before starting, okay, how to write the need sketch, first you should draw 7 circles. Okay, 1, 2, 3, 4, 5, 6, 7. So with appropriate distance, okay, you should write. You start writing first this circle, then this one you write, then this one, this one, this one, this one and this one. Starting only, don't write outer circle. Okay. So this middle one is shaft. Okay. After writing this, now draw next to these 2 circles, and after writing that, you mark vertical lines like this. Okay. Like this you write with appropriate distance. You write almost equal distance, you write. So what I am writing, this is called commutator with segments. Okay, it is nothing but commutator with segments. So after writing this, next you should write brushes. The brushes will have fixed contact on the segments. So this green color what I am writing now, it is called brushes. So this we can call it as brushes. See, after this, next you have to write armature core. How to write that? Look at here, observe carefully how I am going to write. See guys, you should write all these circles with thin lines. Don't write thick lines. Write thin lines, only visible for you. Like that you write the circles, because I am going to do some modifications, so that if written lightly, later you can erase it. So write like this. Okay, write the wedge shaped armature slots. Okay, like this you write. So you should write like this. Understood how I'm writing? So you should write like this. Wedge shaped slot. See, like this you should write. Okay. Like this. And you should join this side. So in the open space, you should write the conductors. In that manner you should write. So observe carefully. So how I am going to write? Okay, extend like this, draw line like this, and join this two, and erase this part, and erase this one. Understood? So like this you complete this entire circle. So write neatly. So like this you start erasing all this. So write neatly. That's why if you written thin lines, you can easily erase it. Okay, like this you should write. See, after writing this, so this is called armature core. This entire thing is called armature core. Now inside this you write the conductor. Wherever open is there, there you write the conductor. So draw one small circle and draw two lines inside that. Okay. What are all these? These are all conductors. Okay, armature conductors. Understood? So I covered everything. So next part is you should write the poles. So how to write poles? See, from this point, okay, from this point you extend a vertical line, and here also extend a vertical line, and write like this. Okay, and finally, so you take some angle, so expand this with certain slope, and this point or this point you just join with some arc. Okay, join with some arc. So I join it. So like that you write all the four sides. So vertical line, vertical line. So extend this lines and draw some slope line and join these two tips. Approximately you write. Okay, you need not write perfect diagrams. Approximately. So you should write in such a way that somewhat the evaluator will get impressed. He should feel happy. Yes, that student is written little good. Okay, that impression you should make it on the examiner. In that manner you start writing. Okay, like all the four sides you write like this. So vertical line, extend like this. See, observe how I am going to write. So first I should write like this. Then I should join both the tips with some arc. Understood? See, now erase this part. Erase this one. See, what these are all poles. Okay, what I written just now, it is poles. The poles are fitted to the yoke. Understood, guys? See, now you must draw the field windings. Draw the field windings. See, you take one wire here from this point onwards. You just join like this, and you just encircle this winding on the core. So in this manner you can write. So it is wounded on the pole core. This remaining part will come here. So that will go and enter into this pole, and that will get wounded n number of turns. Again that is return back to another pole. So now again join like this. Okay. So please write as neat as possible. So write neatly. So join this, and like this you should complete for all the poles. Finally you take outside. So this is plus and this is minus. Here you write DC supply. Okay, DC supply. So this is called field winding. Okay. So what I wounded on the pole cores, that is called field windings. Finally, for this entire machine, what is required? We require one stand to place it at to place it on the ground. We require stand. So that we can write like this. So just write some little curvature. So draw an horizontal line. Okay. Now the machine is placed on the ground. Okay, write like this. See, very easy now how to write the construction of a DC machine. It is very simple. So this completes the sketch. So next is label the parts. Before labeling the parts, you just mark the current direction for field winding. See, whenever this winding is given to this supply, current starts flowing through this winding. So the direction of current, it will go like this, and again it will start flowing in the conductor in this direction. Okay, it will go like this, come out, and again it will come and it will go in this direction, again it will come out. Okay, it will go back and again it will come like this. See, like this you should finish it. the winding current directions. So this one is called north pole. Okay, this one is north pole, this one is south pole. Okay, north pole and south pole. See, I finished all almost I completed the sketch. Later I won't write anything regarding any figure adjustments and all. We can label the parts. See, this outer circle, what is called, that we can call it as yoke. The outer circle is called yoke. Okay, later I will tell the functions of that also. See, outer circle is called yoke. And this one, okay, see this diagram I will write separately and I will label the parts separately. So like this, it is there. Okay. So this is fitted here. This is fitted. This is called, that entire arrangement is called pole. The pole is fitted to the yoke. So then what is this part? See, this vertical line is there now. That is called pole core. That we can call it as pole core. Okay. And this, from here to here, this is called pole. Okay, pole show. Okay, this we can call it as pole show. Okay. And this curvature is called pole arc. The curvature is there now, that we can call as pole arc. And this end points, we can call it as pole tip. Okay, the end points is called pole tip. So this is also pole tip, that is also pole tip. We have two pole tips, leading pole tip and trailing pole tip. That is higher level topic that you need not to worry more regarding that. So initially you just know the basic parts of the respective pole. So this is called pole core, this is called pole show, this curvature is called pole tip, and the curvature is called pole arc, and this end points, okay, the sharp edge point is called pole tip. Okay, so this completes regarding pole. So next this entire thing. Okay, this entire thing is called pole core. Armature core. Okay, sorry for that. See, this entire thing. Okay, this conductor, armature, this open part is there now. That is called armature slot. And this closed portion, that is called armature tooth. See, this tooth, armature conductor, and this entire thing is called armature core. Armature core consists of following parts. See, the first one, okay, this green color, inside one, green color, is called armature winding. So it is nothing but armature winding or armature conductors. So next, this one, okay, this part is called armature tooth. Okay, that part is called armature tooth. See, this one, closed one, that is called armature tooth or teeth. Both are correct. So next is, see, this open part, this open is there now, this one. I will erase for understanding purpose. See, now it is open, empty slot. Okay. Now this is called armature slot. So this one we can call it as armature slot. So armature consists of what? Armature core consisting of armature slot, armature tooth, and armature winding. Okay. So next, what about this green color? So this green color one, okay, this box one, that is called brushes. So BRUSHES, brushes. And finally, this one, okay, this complete circle with red lines, that all together is called commutator, commutator, commutator with segments. Commutator with segments. Understood? So this entire circle is called commutator with segments. And this one, this middle circle, chota circle, okay, this one is called shaft, okay, also called armature shaft. Okay, got it? Understood, guys? And this entire machine is placed on the ground, so we can call that is ground or base. We can call it as ground or base. Understood, guys? So up to here, if they ask this question for 8 marks, if you write a neat sketch and labeling the parts perfectly and correctly, then you will get 4 to 5 marks. 4 to 5 marks. For explanation, 3 marks will be there. Okay, for explanation, 3 to 4 marks they will give. One more, I missed it. So this one, okay, this green wire, okay, this wire is wounded now on the pole core. So that this wire is called field winding. This wire we can call it as field winding. So next part is we have to explain all these parts. So I will explain. So listen carefully and then write it down in your notes by pausing the video. Pause the video and then copy down whatever I explained, each and every part. Okay, let's start with yoke. What do you mean by yoke? See, the main function of the yoke in this DC machine is it acts like a protecting cover for the entire frame of the machine. It acts like a protecting cover for whole machine. And another one is the yoke provides low reluctance path. The yoke provides low reluctance path. What do you mean by reluctance? Opposes the creation of magnetic flux. Okay, it is analogous to resistance in electrical circuit. Means between north and south pole there will be lines of flux. So the lines of flux should travel. To travel the flux from north to south, okay, we need some path. So yoke acts like a magnetic path. Okay, and because yoke is made up of having low reluctance. Understood? Fine. Later, the yokes are made up of cast iron or cast steel. For smaller rating machines, cast iron is recommended, and for large rating machines, cast steel is recommended. So all these things you should write regarding the yoke. So next next part is pole. Okay. See, the pole is also made up of magnetic materials. Okay, with having silicon steel laminations. However, it is having good magnetic properties. Such laminations they are going to use. So actually, we don't have this ready-made core available in the market. We get a lamination silicon steel. They are going to cut the lamination silicon steel with this desired shape. Later, they will join n number of laminations side by side and stamp it together. Then you will get required size of the pole core. Okay, required size of the pole, and that pole is fitted to the yoke with the help of the bolts. So that bolts will be inside. We cannot show that in that diagram. Okay. Next, in that pole we have 3 to 4 parts. One is called this vertical line. So this vertical line is called pole core. Why it is used? So the major function of the pole core is to carry the field windings. So whatever the winding is there, we can wound that winding around the pole core. So for that purpose, the poles are extended vertically downwards. Okay, certain distance vertically it is extended. Okay, field winding is not required. You can reduce this length. You can reduce that length in order to wound the windings, field windings. So that is a major function of the pole core. In general, it carries the field winding. The major function of pole core is going to carry field windings. Next is pole show. Okay, so pole show provides mechanical balance to spread the flux. See, whenever this field winding excited by supply, current start flowing in that field winding. So that current produces a magnetic field. So whatever the magnetic field is there, so that magnetic field should spread around the armature conductors. Around the armature conductors, so this is armature conductors. Whatever the flux produced by the pole core, I need to spread that flux, okay, around the armature core. So in order to spread the flux, we need some additional mechanical design. For that purpose, they extended in this way. That is called pole choke. Okay, it provides mechanical balance and spread the flux around the armature circumferential distance. See now, pole tip. Pole tip is maximum amount of flux can spread till that point. Okay, that is called pole tip. And pole arc. See, the pole arc is made exactly, this outer circle is there now. For that circle, this pole arc is parallel. So in that way, the arc is there. So if that we can maintain exactly this arc parallel to this outer circumferential distance of an armature core, we can spread the flux equally around the armature core. That is the major function of the pole arc. Okay. So what poles are made up of? Poles are made up of silicon steel laminations. N number of laminations are joined together and stamped together to get required size of the pole. Okay, got it? Then, see, next part is armature. Armature core. See, this entire part, even this empty space, this everything is called armature core. Okay, this whole thing is called armature core. See, armature core is nothing but a certain length of conducting material wound for desired shape and size in order to satisfy electrical and mechanical requirements. So that is standard definition of armature core. Once again I will tell, a certain length of conducting material wound for desired shape and size in order to satisfy electrical and mechanical requirements. That is nothing but armature core. Next, it consists of two parts. Armature slot, one is called armature slot, another one is armature tooth, and next one is armature winding. Then look into armature slot. What is the major function of the armature slot? The major function of armature slot is we can house the armature conductors. What we can do inside the slot? We can put the conductor in that slot. That is a major function of the armature slot. So the armature slot, okay, will going to receive the armature windings, okay, or we can house the conductors inside the slot. So generally the armature slots are made like wedge shaped, okay, wedge shaped, like this, wedge shaped. If I place the conductor here, if I make wedge shaped, when armature is running, the conductor should not come away from that. So for that purpose, the armature is wedge shaped. So if I place conductor here, when rotating, the conductor will not come away from the slot. Okay. So in that way, so it is designed. If I made parallel slot like this, okay, when rotating, this conductor may come out of the slot. That's why they are going to make like this. If they make like this, now this conductor will not come away from the slot. So for that purpose, armature tooth plays important role. When armature is running, the conductor should not come away from the slot. For that purpose, this armature tooth will provide mechanical balance. Okay, got it? The armature tooth will provide mechanical balance. Understood, guys? Again, the armature core is made up of cast iron or cast steel. So it is having less magnetic properties. So understood, guys, about armature core. And the next one is commutator. Okay, commutator or segments. See, there will be a number of segments. So generally, commutator is nothing but split ring. Commutator is nothing but split ring. So the major function of the commutator is, in case of a generator, the commutator going to convert induced AC quantity into unidirectional quantity. That is major function of commutator in case of generator. In case of motor, the function of commutator is to convert pulsating torque into unidirectional torque. So these are the major functions of the commutator. Next is brushes. So what is the major function of the brush? The brushes will going to collect the induced quantity from the commutator segments. But the commutator is rotating. The brushes will not rotate. The brushes will have fixed contact on the segments, commutator segments. Then where commutator segments collect induced quantity? Commutator segments will collect induced quantity from the armature conductors. See, this all armature conductors are connected in series and are placed to the commutator segments. So if armature of conductor is rotating, segments also rotating, but while rotating, the brush will have fixed contact on the slip rings. So based on that contact, we can receive induced quantity from the brushes. Whatever you received from the brushes, that voltage you can give it to the external load. Okay, got it? So generally, the brushes are made up of carbon or copper. Okay, and sometimes we can use graphite brushes also. Understood, guys? So this about detailed construction of a DC machine. 6 to 8 marks they are going to ask. Okay, explanation means you try to explain each and every part in a machine. Okay, if you prepare each and every part, at least you can write 3 to 4 parts in exam. Okay, that is also good. Understood, guys? So whatever I explained the function of each and every component, you pause the video, listen it, and then write it down. Okay, it takes, however, it takes some time. One time investment. So just spend time on writing all these points. Okay, guys. See now, in the same diagram, I am going to explain working principle of DC generator. Okay, look at here. All these conductors. Okay, all these conductors with green color. Okay, so I will take green only. All these conductors are connected in series. See, armature conductors are connected in series. Sorry, I didn't say what is the definition for armature winding. See, armature winding is nothing but an array of conductors are connected in series. An array of conductors are connected in series so that desired magnitude of EMF is induced in it. So that desired magnitude of EMF will be induced. That is called armature winding. So we have two types of windings, lap winding and wave winding. That I will explain in the next class. Okay. See, all the conductors are connected in series. Okay. Now, between the magnets north and south pole, there will be lines of flux. There will be lines of flux. So I am going to write like this. There will be lines of flux from north pole to south pole. Okay, there will be lines of flux. See now, all these conductors, all these conductor ends are connected to the segments, are connected to the commutator segments. All these conductors are connected to the commutator segment. See, generally, actually I written more number of segments. If I written more number of conductors, each conductor is connected to respective segments. Okay, keep that in mind. But it is not exact diagram. Okay, it is not exact machine diagram. Almost like this only. Actually, for every segment there will be a connection of the conductors. Armature conductor coil ends will going to connect to the respective segments. depending on type of winding. See now, this entire commutator segment is mounted on the shaft. See this armature, commutator segments, everything is mounted on the shaft. What do you mean by generator? Mechanical to electrical is called generator. So this shaft is coupled to the mechanical input. Let's say turbine. So the turbine shaft and this armature shaft are coupled together. Whenever water falls from the turbine, turbine rotates. If turbine rotates, the armature also rotates. Whenever these rotating conductors cut the flux, whenever these conductors cut the flux, EMF will be induced. That induced EMF is collected by the brushes, and this voltage we can give it to the external load. So in this way, so the current starts flowing through the load. Understood, guys? So like this, the generator works. Understood? So the next another part, why field winding is required. See, sometimes we are going to design to develop 300 volt machine. So from the available poles, we can get only 100 volts. But what is my target? 300 volts. But I am getting from the magnetic poles, okay, with 100 volts. Now I need to get additional 200 volts. For that, what I required? I required additional flux. I need excess flux. So under that condition, we can place the field windings on the pole cores. We can place the field winding in the pole cores. We can excite that field winding by supply, which carries current. That current produces magnetic field. That magnetic field going to spread around the armature conductors, and hence more rate of change of flux takes place. Under that condition, you get more induced voltage. So whenever your induced voltage is not reached your expectation, under that condition, you should excite the field winding and produce necessary flux. Okay. Then you will get required voltage. What you expected, that voltage you can predict by exciting the field coils. When flux is not sufficient, you just connect the field winding to the supply, excite it, then you will get flux. Required flux you will get to reach your target induced voltage. Understood? So material, which material is used? See, field windings are made up of conducting material, and we are going to use copper or aluminum. 99% we are using copper because it is malleable and ductile. We can bend the copper according to our requirement. It won't lose its tensile strength compared to aluminum conductor. Similarly, the armature winding is also conducting material. So it is, we can go for copper or aluminum. But copper is recommended in most industrial applications. Okay. Very for small machines, we can go for aluminum conductors. So I didn't see much machines with aluminum conductor as a winding material. I seen so far copper only. Okay. However, they can use, but only for small machines. Okay, guys. I hope you understood the construction of DC machines. So thank you for your patience to watch this video entirely without forwarding. So in the next video, I am going to upload types of generators, its voltage and current relations. So all types of voltage and current relations I am going to cover in one video itself. Okay, it may cross 30 to 45 minutes. Okay, but I request you to watch entire video so that you can understand in a single stretch. In one stretch you get all the concept. Okay, so that I will be posting tomorrow evening. Okay, so have a nice day. Take care. Please like our channel, subscribe my videos, subscribe and tell your friends to subscribe my channel. Okay, so please keep supporting to me. So I will try to do all videos, okay, within April 10th. So I try my best. Okay. However, power conditions, power cut in our areas. Okay, if such conditions happen, means the video uploading will get delayed. So thank you. Have a nice day. Take care. Bye bye.